All right, so good morning, good afternoon, good evening, everyone, depending on where you are. And welcome to our session on the latest advancements in Azure's Web Application Firewall. My name is David Frazee, and I'm a product manager on the customer experience and engineering team for Azure Network Security. I'm joined today by my esteemed colleague, Shabaz Shaik. Together, we'll be diving into the essential updates and enhancements of the new default rule set, DRS 2.1, that is now available for both Azure Front Door and Azure Application Gateway. If you have any questions during the presentation, please feel free to put them in the chat as we present. We have a great team joining us today that will be monitoring the chat and will try to answer as many questions as they can. And as mentioned, if we have time at the end, we'll take some moments to address any unanswered questions or questions that would be beneficial to the community. Today, we're going to explore several key areas. We'll start with a brief overview of Azure WAF and its pivotal role in securing web applications. Following that, we'll introduce the new DRS 2.1 and discuss its updates and enhancements in detail. We'll also cover the practical implications of these changes and how you can leverage them for better security. In addition to the DRS 2.1 updates, we'll delve into the Bot Manager Ruleset 1.0. We'll also cover the new features such as rate limiting and log scrubbing on Application Gateway and custom rule cloning for both delivery platforms. We'll introduce Azure WAF workbooks, which provide a visual representation of security-relevant WAF events across several filterable panels. These workbooks are invaluable for triaging and analyzing WAF logs. And to bring all these concepts to life, we'll present a live demo showcasing how these new features and enhancements can be applied. Lastly, we'll wrap up with the Q&A session where we'll address any questions you may have. So let's get started with our overview of Azure WAF. In the digital age, web applications are the gateway to our data, services, and operations. As such, they are prime targets for a variety of cyber threats. To safeguard our digital assets, understanding and mitigating web applications attacks is paramount. So we'll start with DDoS attacks. So distributed denial of service or DDoS attacks aim to overwhelm web applications at multiple layers. Layer 3 and 4 attack target network infrastructure, while Layer 7 attacks, also known as application layer attacks, target the very heart of our web services. Azure's DDoS protection, coupled with Azure WAF, provides a robust defense system filtering out malicious traffic and ensuring web service continuity. For web application attacks, these are sophisticated attacks targeting specific application vulnerabilities, such as SQL injections, cross-site scripting, and remote file inclusions. Azure WAF leverages the OWASP core rule set to defend against these threats, providing a layer of security that adapts to just evolving tactics of cyber adversaries. And next, we'll talk about malicious bots. So these automated programs scrape data, probe for vulnerabilities, and perform credential stuffing. They can cause financial loss, competitive disadvantage, and even legal challenges. Azure WAF's Bot Manager Ruleset is designed to detect and block such malicious activities, protecting your applications from exploitation. And the cost of these attacks, they extend beyond just the financial loss. They can erode customer trust and damage, or actually they can damage a company's reputation. However, with tools like Azure WAF, we can mitigate these risks and secure our applications against the changing landscape of cyber threats. Azure Web Application Firewall, or Azure WAF, stands as a guardian of enterprise compliance standards, offering a platform-managed solution that simplifies the protection of your web applications. Whether your applications are hosted in Azure or elsewhere, Azure WAF ensures high availability, scalability, and performance. It is adept at protecting against a spectrum of attacks, providing quick responses to emerging threats. Integrated seamlessly with Azure Front Door at the network edge, it combines application acceleration, caching, and robust protection. Azure WAF also integrates with Application Gateway, offering dedicated protection for both public and private websites, ensuring your web applications are safeguarded. Azure WAF is equipped with pre-configured rules to guard against the OWASP top 10 threats, providing a solid foundation for web application security. The integration with Microsoft Threat Intelligence enhances bot protection, leveraging global insights to block malicious automated threats. Conditional rate limiting at the Azure Network Edge helps manage traffic flow, preventing overload and ensuring service availability. The powerful custom rules engine allows for tailored security measures, while geo-filtering and IP restriction capabilities add an extra layer of control. HTTP parameter and size restriction features further refine the protection, ensuring only legitimate requests are processed. Azure WAF's logging and metrics provide detailed insights for detection and alerts, allowing for prompt response and remediation through Sentinel, through Sentinel integration. The ease of configuration across various platforms, including Azure Resource Manager, Portal, API, REST API, Azure PowerShell, Azure CLI, and Terraform, makes Azure WAF a versatile and user-friendly solution for securing your web applications. So now we'll discuss the actual WAF managed rule sets. So I am excited to talk about the latest iteration in our web application security arsenal, and that's DRS 2.1 or Default Rule Set 2.1. This rule set is not just an update, it's a significant leap forward in protecting our applications from just an ever-evolving threat. DRS 2.1 is built upon the foundation of OWASP CRS 3.3.2, which is the standard for web application security. This means we're starting with a comprehensive set of rules that are widely recognized and respected for their effectiveness in thwarting common web vulnerabilities. What sets DRS 2.1 apart is the integration of Microsoft Threat Intelligence Center rules, or MISTIC rules. These rules are the result of a meticulous analysis and research by our cybersecurity experts, providing an additional layer of protection against specific vulnerabilities and attack vectors that are relevant to our ecosystem. One of the most significant features of DRS 2.1 is also anomaly scoring. The system provides a more nuanced approach to threat detection, assigning scores to requests based on their level of deviation from the norm. By setting thresholds, we can fine-tune our response to potential threats, ensuring that we block malicious traffic while minimizing false positives. Now, anomaly scoring came out in DRS 2.0 and with CRS 3.2 in the application gateway, but this approach has incredible value to the overall tuning of the Azure WAF. So we'll discuss this a little bit more in another slide. And then speaking of false positives, DRS 2.1 excels in reducing these frustrating occurrences. Through continuous refinement in the application of MISTIC rules, we've been able to decrease the noise and focus on genuine threats, thereby reducing the operational overhead of our security teams. So kind of put it all together, benefits are DRS 2.1. So it's the latest rule set. DRS 2.1 represents the most up-to-date rule set, ensuring applications are protected against, the latest known vulnerabilities. It's based off OWASP CRS 3.3.2. So by basing on this, we leverage a community-driven, widely adopted set of rules that have been battle-tested across diverse web environments. We also have MISTIC rules. So the inclusion of MISTIC rules means that our applications benefit from Microsoft's extensive threat intelligence and research, providing targeted defense against emerging threats. With anomaly scoring, this mechanism allows for a more granular and intelligent response to potential threats, reducing the likelihood of blocking legitimate traffic. And then lastly, false positive reduction. We've made significant strides in reducing false positives, streamlining security operations, and ensuring a smoother user experience. Now, the Microsoft Threat Intelligence Center, or MISTIC, plays a crucial role in fortifying the security provided by the Azure WAF. MISTIC's expertise in threat intelligence is leveraged to develop rules that are specifically designed to protect against zero-day vulnerabilities and common exploits such as SQL injections and cross-site scripting. These rules are meticulously crafted to provide immediate and effective protection against new and emerging threats. So MISTIC rules are not generic. They are tailored to address the unique threats faced by web applications today. By focusing on zero-day vulnerabilities, MISTIC ensures that Azure WAF can respond to attacks that exploit previously unknown vulnerabilities in software. This proactive approach to security is crucial in a landscape where attackers are constantly seeking new ways to breach defenses. The development and testing of MISTIC rules, it really involves a collaborative effort between MISTIC and the Azure WAF teams. This partnership ensures that the rules are not only based on the latest threat intelligence, but also tested rigorously to minimize false positives and maximize the protection. The collaboration extends to the rapid deployment of new rules, ensuring that Azure WAF can respond swiftly to new threats as they are identified. One of the standout features of MISTIC rules is their real-time aspect. So as new threats are identified, Mystic works diligently to publish and update rules in Azure WAF, providing immediate protection to web applications. This real-time response is critical in an environment where threats can emerge and spread rapidly. The agility of Mystic and Azure WAF teams in publishing new rules is really a testament to the commitment to the security here. As soon as a new threat is identified, Mystic develops a rule to counter it, and the Azure WAF team ensures its quick publication. This process provides web applications with the most up-to-date protection possible, reducing the window of vulnerability to new attacks. And I do want to kind of talk on this piece where we show here in a slide that some rules may replace another rule. So some Mystic rules were just created to be a little bit better when it comes to false positive reduction. And so maybe the signature behind this is just a little bit more efficient. So in this example here, rule ID 942440, that is an OAuth's core rule set type rule. But we would actually, if you to utilize DRS 2.1, we would set that rule 942440 to disabled, and we would enable the Mystic rule that would be its counterpart there. Mystic does have a few rule groups. We have threat intelligence AppSec, SQL injection, web shells, and CVEs. We'll kind of see a little bit more here. Yeah, so here is a list of the additions to DRS 2.1 as of today. So we do have additional rules in protocol enforcement, protocol attack. So these are part of the OWASP, the OWASP rule set. And then when it comes to the actual Mystic type rules or the Microsoft Threat Intelligence rules, we have a few new ones for web shells and SQL injection, but as you can see, our CVE list has grown exponentially here. So any type of new CVE that we are identifying that could potentially impact your web applications, we immediately throw it into this rule group here. And so for DRS 2.1, these are the additional rules that have been added compared to DRS 2.0. So now let's talk about anomaly scoring. So we did have originally anomaly scoring and then traditional detection mode. Traditional detection mode was the default behavior before then. So traditional detection mode, this method, was the default for Azure WAF. It operates on a binary system. So each rule is independent with no shared intelligence between them. And when a rule is triggered, it executes specified actions, whether disruptive or logging. This mode, while straightforward, it can be laborious to tune, as it requires numerous iterations of the same request to ensure that all false positives have been addressed. For anomaly scoring, this is a shift in threat detection. Anomaly scoring introduces a dynamic and nuanced method. So instead of a binary trigger, it assigns scores to traffic based on deviation. This allows for a more sophisticated analysis, considering the cumulative behavior of requests and enabling a context-aware response. So the benefits of anomaly scoring, it's adaptable. It swiftly adapts to the new threats, not relying on predefined signatures. It does reduce false positives, as not all anomalies will trigger an alert. So you can check the threshold, see what's actually being triggered, and determine how you would like to tune the Azure WAF. It does help with early detection, so it detects threats in their infancy before they match known attack signatures. When it comes to contextual analysis, it provides a more accurate assessment by considering the context of the traffic as a whole, rather than just seeing a certain part, a certain rule gets triggered, and then we go. For the different severity levels, as you can see here, we have 4 different severities: critical, error, warning, and notice. For notice, this is a minor deviation and it's assigned 2 points. Warning is a moderate concern, error is a significant issue, and critical is a severe threat. So most inbound threats are scored at 5 by default, while lesser violations, they will carry lower scores. And this scoring reflects the overall risk and deviation from the expected behavior. This version of Azure WAF uses anomaly scoring, DRS 2.1, making a departure from the traditional mode. With anomaly scoring, rules can share information about previous matches, leading to a more informed and effective defense strategy. And to just kind of touch on that a little bit more, when we're talking about traditional detection mode, if this wasn't clear for you, so let's say you send a request to your Azure Front Door or application gateway with WAF enabled. In traditional detection mode, let's say there was some form of SQL injection in that. The first SQL injection rule that is hit would immediately block the traffic. That's the only block that you would see in the log. And if you thought that that was a false positive, you would have to then create your exclusion, potentially a custom rule, or change the action on that specific rule ID that was triggered. But then the issue is if you were to send it again, thinking, okay, hey, I've done my work here, and it blocks again, because there was an additional SQL injection rule that would have been triggered by this that had a critical score. You would have to keep going through iteration and iteration, while anomaly scoring would just show you as a whole each and every rule that's hit during that one single request, and then you can determine exactly how to tune with just one request. Then let's say 10 or more requests just to tune one false positive. And then here we have the Bot Manager rule set. So this is powered by the Microsoft Threat Intelligence feed. It is a bot mitigation rule set list of known bad IP addresses, and this does update multiple times per the day through the Microsoft Threat Intelligence feed. There are 3 different Bot Manager rule set groups. There are going to be bad bots. So there's 2 rules that are specifically in the bad bots. And then there's going to be good bots, of course. So these will be really search engine crawlers. So, things for your SEO, search engine optimization here. These bots would be kind of allocated into that. And then we have unknown bots. So these are bots that, maybe we don't have any information on them. They aren't really looking malicious here. Maybe there's some information missing here, but they're not necessarily bad. But we will log them as an unknown bot. What's great about this is that you can change the actions though. So if you don't trust the unknown bots and you don't like that the action is logged, you could easily go into this rule set and then say, hey, anything, let's say in rule 300/100, unspecified identity. I don't trust that. I want to block that. You can go and you can change the action to block, and then you won't have to worry about that anymore. You do have the ability to make exclusions on bot manager rules. It's not just with the more default rule set there. You could do this on the bot manager as well. And the latest rule set today is 1.0. There was one called 0.1, but if you want to utilize the most advanced bot protection that we have today, that would be for you would be using the latest rule set, which is bot manager 1.0. And now I will be handing this over to Shabaz.
Thank you, David. Give me one moment. I'm going to be sharing my screen here. All right. Hello, everyone. This is Shabaz, and I'll be taking over from here and talking about some of the new enhancements that we have in Azure WAF, starting with the rate limiting custom rules. So before we jump into the rate limiting, let's first get some context here. So let's talk about the HTTP DDoS attacks. So HTTP DDoS attacks aim to overwhelm a web server or application with a large number of HTTP requests, such as GET or POST requests. So these requests are often sent by a botnet, which is a network of compromised devices that are controlled by an attacker. These attacks can exploit different versions of the HTTP protocol, such as version 1.1 or version 2. So the HTTP version 2 is a newer version that offers improved performance and efficiency, but it can also be abused by attackers to launch more powerful attacks. For example, just recently, a campaign of hypervolumetric HTTP DDoS attacks exploited a vulnerability in HTTP version 2 called Rapid Reset, which allowed attackers to send millions of requests per second to targeted servers. Now, to ease your minds, this flaw has been mitigated already within the application gateway and front door platform so that the amplification vector of this attack is stopped. However, this is still a flood of requests that targets a single endpoint, so you still need to utilize various methods to protect your applications, such as using a web application firewall and implementing rate limiting rules. So that's where we talk about the Azure WAF rate limiting. So rate limiting enables you to detect and block abnormally high levels of traffic destined for your application. By using rate limiting on App Gateway WAF, you can mitigate denial of service attacks. You can protect against clients that have accidentally been misconfigured to send large volumes of requests in a short period. And you can also control traffic rates to your site from specific geographies. So like the functionality that exists currently in Azure Front Door, customers will now be able to create rate limit rules on App Gateway WAF, and they can set a threshold and time window for incoming requests. When requests exceed the threshold within the chosen time window, traffic matching the rule will be rate limited. Azure WAF on Application Gateway also introduces group by user session as an additional control for customers, which specifies how requests are grouped and counted for matching a rate limit rule. This functionality will greatly enhance the flexibility and power of the rules when mitigating the distributed floods, as these rules can be created by grouping traffic by different variables rather than just the source IP addresses. The supported group by variables are client address, geolocation, and none. Rate limiting on App Gateway WAF uses an enhanced sliding window algorithm to determine when traffic has breached the threshold and needs to be dropped. During the first window where the threshold for the rule is breached, any additional traffic matching the rate limit rule will be dropped. Starting from the second window onwards, traffic up to the threshold within the window configured will be allowed, producing a throttling effect. So this algorithm is highly effective at enforcing smooth threshold window, and it is in line with customer expectations of rate limiting functionality. Now, let's move on to the next topic, which is sensitive data protection. This is mainly about data leaks. So data leaks could originate from a sophisticated cyber attack that utilizes a layer 7 DDoS attack followed by secondary web application attack. The cost of a data breach today can be very significant. So according to the IBM cost of a data breach report 2023, the global average cost of a data breach in 2023 was 4.45 million USD, which is like a 15% increase over the past 3 years. This cost includes both direct and indirect expenses suffered by the breached organization. Now, the Azure Application Gateway provides customers with the ability to log WAF event data for future debugging and analysis, as we know. Because this data is stored in logs as plain text, and because some of the data getting stored might contain sensitive customer PII, which is personally identifiable information, our customers wanted the ability to scrub certain fields from their data before it gets stored into the log files. For example, if the WAF is triggered by a suspicious login attempt, it might log the username and password used during the login. In this example, the app owner would want to prevent that username and password being stored within the log. The same example would be true for other scenarios and PII, such as authorization credentials, credit card details, or IP addresses, etc. So the Azure WAF's log scrubbing tool helps you remove sensitive data from WAF logs. It works by using a rules engine that allows you to build custom rules to identify specific portions of a request that contain sensitive data. Normally, when a WAF rule is triggered, the WAF logs all the details of the request in clear text. If the portion of the request triggering the WAF rule contains sensitive data, such as customer passwords or IP addresses, that sensitive data is viewable by anyone with access to the WAF logs. So with log scrubbing rules, once a match is identified, the tool scrubs that information from your logs and replaces it with a bunch of asterisks like we see in the screen. The following match variables are available, which are request IP address, request header names, cookie names, org names, host org names, and JSON org names. So all of these match variables are case insensitive except the request header names. Sorry, I apologize. All of these are case sensitive except the request header names, which is case insensitive. Now let's move on to the next section, which is custom rule cloning. So the custom rule cloning gives a provision to copy an existing custom rule in the same policy or to another WAF policy as needed. This feature reduces the configuration overhead if you'd like to replicate a similar rule in multiple policies. So as we can see on the screen here, once we get into the custom rules section, And we get these two options, like duplicate this policy or copy to another policy. So we can select a specific custom rule and we can duplicate it in the similar policy, same policy, or we can also copy to another policy by just making some parameter changes. I will also show this in the portal directly once we get to the demo part. Now, these are some of the recent features that we wanted to present, and moving forward, the other items that I wanted to cover was Azure WAF workbooks. So primarily, we have two workbooks as of today, which is the first one is the Azure WAF Monitor workbook. So this workbook visualizes security relevant WAF events across all several filterable panels. So this will give you comprehensive information on all the traffic that is passing through the WAF. It will give you information on the top blocked requests, messages, events triggered, and what were the actions taken and everything. So this is a single dashboard with all of this information available at a single pane of glass. So if you look at these tabs here, we have logs at one section. We also have metrics for app gateway and front door. So we can get as many details as we want related to our current setup and the traffic that it is processing. Now, moving on to the next workbook. So the next workbook we have is the Azure WAF Triage workbook. So this workbook visualizes application gateway WAF rule violations and helps with triaging those to facilitate tuning the WAF against valid traffic. So tuning Azure WAF is definitely a comprehensive task involving parsing of logs and triaging which requests are false positives and which ones are true violations. So especially during the design phase of an application, it is important to review these logs and make sure to adapt the application or WAF configuration to eliminate the false positives. So this is where this type of Azure WAF triage workbook will be very helpful. Now let's move on to the demo part. So here I am at the Azure portal. I quickly want to show one of the policies that we have for the application gateway. So let's just open that. So SOC NSAG policy is our demo policy that we wanted to show here. So when we go to the managed rules section under the settings tab, as we can see what rules are currently assigned to our policy. So if we expand this, we'll be able to see all the details and signatures, rule IDs and everything. So that is really helpful. And if we want to change any actions for these rules, we can do that as well. Similarly, same thing for the default rule set. So all of these rules are currently set to anomaly score, but however, we can change the action by just selecting one of these rules and changing the settings from here. And if at all we want to change the rules that are assigned, we can simply go to this particular tab here and click on assign. And as we can see, we have the option of selecting the default rule set. We could either select any one of these, and we can also select the bot rule set that we require. Now, let's move on to the next section, which is the custom rules section. That is where I wanted to cover a couple of topics, which is the first one is the rate limiting. So as we can see here, we have a bunch of custom rules that are configured, but this is the rate limit rule that we have. So if we go to this rate limit rule and see, there is the rule name that is assigned, and we are just enabling this rule. And contrary to the previous custom rules, this is a rate limit type of custom rule. And we'll assign a priority to it, whichever we want as per the rule processing that we need. And the most two important factors that we are configuring here are the rate limit duration and rate limit threshold. So here what we have configured is 1 minute as the duration and the threshold is 2 requests. So this is just for demonstration purposes, but you can have whatever required threshold that you need in your environment. And there is also this group rate limit traffic by, which I discussed while explaining the rate limiting feature. So right now it is currently selected as none. And if we go further down, we can see in the conditions that the match type is a string that we have selected. The other match types are IP addresses, numbers, and geolocations and all that. And if we select a string, and we've also selected a match variable, which is request URI. So what we are trying to say here is if the request URI contains login and there are more than 2 requests that are coming in a duration of 1 minute, then block the third request. So that is what we are trying to say with this particular rate limit rule. So this is very simple to configure, and we can get as flexible as we want because we have so many options to configure here. So this is one of the ways we can configure and protect our applications from HTTP DDoS attacks. Now moving on to the next item, which I quickly wanted to cover, is the cloning of these custom rules. So we have two options here. We can either duplicate a certain custom rule within the same policy, or else we can duplicate a rule to another policy. So if I select one of these rules, let's say I'm selecting this Sentinel block IP and click on this duplicate in this policy. While duplication, you can also modify whatever settings you need in this rule, and you can simply click duplicate to create a new rule. So that simplifies cloning of the rules as you want within the same policy. And similarly, if you want to copy this rule to an existing another policy, so just we have to click on the copy to another policy button, and we can select the whatever policy that we want to copy this to, give a name and priority, and that would be copied to that particular policy. So this is really useful for replicating rules from one policy to another. So those are the two items under the custom rules tab. And the last item I wanted to cover was the sensitive data section that we have. So as we discussed, the logs of Azure WAF, they store a lot of information in plain text. So in order to avoid that, we have the sensitive data feature where we can mask some of the information that we don't want to store in the logs. So basically, as we can see here, we have already configured one rule, which is saying that any, so if we drop down on this match variable, we have so many match variables that we discussed. Now in this rule, we have selected the request IP address match variable. So in this rule, what we're saying is any traffic that is coming in, we want to mask the IP address. So in the logs, we don't want to show the IP address there, but this might not be desirable for many organizations. So they can choose what they want to hide or what they want to mask depending upon their requirements. So this gives a lot of flexibility and also peace of mind for whoever is concerned about the PII information getting exposed. So those are the items I wanted to cover for this particular session. But apart from that, these are the new features that we had. But let's look at the workbooks that we have for Azure WAF. So let me go back to the home here, and I'm selecting the log analytic workspace that we are currently using for these demo purposes. So when you open a log analytic workspace and you go to the monitoring section, there is a section called workbooks. So let's click on workbooks and let's filter for WAF. So if I filter for WAF, there are two workbooks here. One is the WAF monitor workbook and there is a triage workbook. So let's take a look at the WAF monitor workbook. So WAF monitor workbook, it is currently loading right now. We have selected a subscription workspaces and the duration is set for last 30 days. And WAF type is app gateway. We can select either app gateway or front door here. And we can also select the resource that we are looking for. So right now, as we can see, a lot of information on a single dashboard is currently available. So for example, login attempts, these many login attempts were blocked. There were these many URIs that were blocked. All of that information that is readily available here. And there is a lot of details on messages, like what are the different messages that you are getting and event triggers and all that. And there are all the logs that were matching the Azure WAF policy. So as we can see, matched, blocked, and all of those details are readily available here. And if we also want to see the metrics for this particular app gateway WAF, we can also see that. As we can see, we have really good graphs on total requests that are coming in and what are the rule blocks, managed rule blocks by rule group, managed rule allows by rule group, managed rule blocks by rule ID and allows by rule ID. so on and so forth. We have different categories here. So you can look at the metrics and you can analyze what kind of traffic is coming in, what were the number of blocks and everything. So this is really useful. And similarly, you can check for the front door metrics as well. But since we've selected the application gateway here, we're just looking at the app gateway tab. So that was the overview of the monitor workbook. So let me go back to the workbook section. And let me open this WAF triage workbook. So this is the second type of workbook that I talked about. Let me select a subscription. And I'm going to be selecting the workspace that I'm working with. And the time, let me keep it for the last 7 days. So this is currently loading, and these are the app gateways that we have. If I expand this app gateway, we can see that these many requests have been blocked and these many requests have been matched by the Azure WAF policy. So if I click on this particular item, the subsequent windows will get populated. As we can see, there is a tab for triage by rule and triage by URL. So let me, for example, select this triage by URL, and we can see what were the host names that were being accessed, or we can see all of those details. And if I select one of those, we can see which paths have triggered firewall rules. So this is getting populated as of now. Let's give it a moment. But the gist of it is it will show you all the details of a particular URL that was matched and what are the rules that were triggered. I think this particular destination is taking a bit of time. However, it just loaded. Let me expand one of these. So if I select this particular request, so there was a 403, and as we can see, there are a bunch of logs related to these requests. So if I specifically want to go and look at this particular transaction ID for that WAF log, I can directly go and find in the firewall log, and we can see more details around that particular transaction ID. So if we expand this, we'll see all the details of that particular transaction and why it was matched or blocked, and what were the different parameters. We can see all that here. So this workbook really helps with all that information. And if we select any of these and the subsequent windows will get populated here. So it's like triaging one by one. So that's why it will be very helpful for tuning your Azure WAF while you are in the design phase or initial phases of configuration. So these are the two workbooks we have. In case you don't have these workbook, or you don't know where you can get these from, so you can simply go to aka.ms/az-netsec. That will open up our NetSec GitHub repository. So in this repository, we have different sections for different products. But however, if you go to the Azure WAF section here, as we can see, we have both the WAF triage workbook and WAF monitor workbook. So let me open this triage workbook. And as we can see, there is a deploy to Azure button. You can directly deploy this workbook to your particular subscription or your environment. Similarly, you can do the same thing for the WAF monitor workbook. We have recently updated this WAF monitor workbook to include the metrics and everything. So this V2, you can use this V2 deployment button to get that. So that is the overview of all the enhancements that we wanted to talk about in this webinar session. So thank you for your time. Just want to hand back to Valen if there are any questions that we need to answer here.
Thank you, David and Shabaz. This was a great deep dive into the latest for WAF as well as the workbook. And let me just see here if we have. Now, we had tons of questions that come in, and the team here is helping with answering them. But here's a few that perhaps we can elaborate a little bit further. So with a rate limiting, does it apply to all requests? we've seen where an application leverages a type ahead prediction that those can be chatty and have issues with the rate limiting WAFs.
Yeah, so rate limiting custom rules, they will be applied to each and every request that comes through. You know, when it comes to rate limiting custom rules, there is a bit of a difference between Azure Front Door and Azure Application Gateway. So Azure Application Gateway does have this group by option that you can utilize. You can group by none, which means, you know, this is a collective, all requests that come in regardless of source IP. You can do a group by source IP, you can do a group by geolocation as well. But when it comes to Front Door, it's kind of opened up, right? So it's a little bit more of around like the group by none. So you don't have that option to kind of select those group by options when it comes to rate limiting in Front Door, but every single request will be ran through the rate limiting custom rule, really dependent, regardless of what the application is in the back end or what type of behavior is going on. Each and every request that goes through the WAF will be processed by the WAF in that delivery platform.
Thanks, David. And talk about the Front Door. Is CDN WAF policy same as Front Door?
So the CDN WAF policy, so that is a little bit legacy, right? So back in the day, you know, Azure had actually, we used to do this offering for CDN, but then there was a lot of movement. Then we went to Front Door, and then actually there was then another movement to more Front Door Standard Premium. So there was originally CDN, then there was Front Door, and we call that now Front Door Classic. And now today we have Front Door Standard and Premium. Everything today that we're talking about is really associated to Front Door Premium. This is a security optimized SKU for Front Door. CDN is legacy. I don't even believe that you can create a CDN, an Azure CDN anymore. And to that extent, then you would not be able to make a CDN WAF policy. I think you can still make Front Door classics and associate, you know, WAF policies to that. But really, if you're looking to have the best security right now today, the most up-to-date rule sets and the most up-to-date features, that is all going to be done at the Front Door Premium SKU.
Thanks, David. Next question is, does Application Gateway WAF supports DRS or only CRS?
So it does support both now. Originally, it was supporting only CRS or core rule set. If you look at the drop-down menu, you'll see CRS 3.2, 3.1, 3.0. You'll also even see 2.2.9. But if you're utilizing that, you may have gotten some type of message that this was going to be retired potentially. But yeah, today now Azure Application Gateway does support both CRS and DRS 2.1.
Is there a maximum threshold limit value?
Yeah, so I saw this question. There is a maximum value for threshold limits, and that maximum threshold is going to be 5. But when you're looking at the logs, you might see a threshold value of like 32 or 12 or 20 or something along those lines. So when we're talking about threshold values and maximum threshold values, we're talking about what is the threshold value that would apply a block to that request, and that number is going to be 5. You'll see a lot of rules, SQL injection, cross-site scripting, remote file inclusion, all of these different ones. A lot of those rules will actually have a threshold value of 5 because they are severe. But then you will see some that are like 1 or 2, maybe potentially 3. But really, to really answer that question, the maximum threshold value would be 5.
Thank you. How do we get access to the workbook that you just displayed? I don't see it on our log analytics workspace currently, and there's also another inquiry related to this where they're not being able to see it.
Yeah, so I think those questions came in, Valen, right before Shabaz was sharing where to actually show that in the GitHub repo. So so Shabaz did kind of show here in the video exactly where in our GitHub repo both of these WAF workbooks are. I think I also put in some links in there in the chat under one of those questions So you'll be able to find both of those workbooks. You can just deploy them specifically to a resource group, associate the log analytics workspace that you're going to use for it, and they'll be able to consume that workbook immediately.
Got it. Well, thanks for sharing that. The next one is it possible to use OWASP 3.2 and MSDRS on the same policy? So one is prevention, the latter one is detection.
You know what? That's a pretty good question. I've never really thought about that. So I'm assuming what they're talking about is for the application gateway today, you have a policy that is associated globally to the entire application gateway, but then you have the possibility to associate WAF policies to either a listener or a URL path map. That's a great question. I've actually never tested this, so I don't have the answer for that today. I'm not sure. I've not really tried to do that. So, but I will be doing that after this. That's for sure.
Thank you. We'll take it as a great feedback. So
yeah,
we'll move on to it.
If anything, I could probably go to the YouTube video that will be after this and just put a quick comment of, yeah, you can do that.
Okay, sounds good.
Yes. I would like to quickly add to what David said for the rate limit threshold, right? So David, I think the number 5 is mostly for the duration, right? It was 5 minutes for duration, but the threshold could be greater than 5.
I'm not sure what you're talking.
So the number of requests, I think it could be as many as we want. There is no definitive number there. But the rate limit duration itself is either 1 minute or 5 minutes.
And then what question was this for, Shabaz? Was this for the one that we were just talking about, or the one?
The previous one for the maximum threshold limit for rate limit.
Okay, I think I got that wrong. So I was assuming that this was the maximum threshold value for a block, not necessarily for the rate limiting. But yeah, so if it was for rate limiting, Shabaz, like you hit it on the nail.
Yep.
Well, somebody replied, and thanks, Shabaz, for adding to that. Appreciate it. But going back to the CRS 3.2, so Ronen replied, we are currently using CRS 3.2 with a lot of exclusions due to false positives. When we migrate from 3.2 to MSDRS 2.1, is it advisable to remove all our exclusions and give DRS 2.1 a chance to work without all the exclusions? He's saying that he did not see a way to export or disable all the existing exclusions.
Yeah, so I mean, that's kind of up in the air, right? It's really going to be what you can do within your environment. If you have a dev environment that allows you, or a sandbox type environment that allows you to say, hey, let's replicate this over here, and then move it to DRS 2.1. We'll set it to its all default behavior and then send some of the same like testing requests that we do just to see what would happen. You could do that. But if you only have like a production environment or some type of stage environment that you're not very, it's going to be a little bit, less lenient there, that, you'll have to make a plan when it comes to that. But, we do always say whenever it comes to actually tuning the WAF to place it into detection mode, so that you can actually see everything that's going through. You won't be really hindered with blocks. Everything will just kind of go through it and you'll be able to peruse the logs. But I would say the best case scenario is to try to replicate the environment in some type of sandbox form, and then change it to DRS 2.1 to see how false positives have reduced in that sense, and then just tune accordingly.
Thanks, David. You explained earlier the difference between the front door and Azure WAF, but the question is it better to use Azure WAF for a new deployment?
So I see the question here, key differences between front door and Azure WAF. So the thing is that Azure WAF is kind of an add-on to the front door, right? So the front door is actually the delivery platform. It's It's really the CDN network. It's where you put your backend applications in, and then your customers are using the front door to actually access and ingress into Azure to get to that web application. The Azure WAF is a security measure that you add to the front door or you add to the application gateway that provides that. So if you have so pretty much the answer is if you have an application that is vulnerable to attacks, which is pretty much every single application out there on the internet, then we would suggest using an Azure WAF, using the front door premium SKU to secure those workloads.
Thank you for that. Mick has a scenario here. He says, if I assign my existing WAF to the new DRS 2.1, are there actions and status? Are the actions and the status preserved?
Yeah, this is a great question. And actually, Shabaz just recently wrote a blog about this. So it depends on really what you're going to do. So if you are going to go into the Azure portal today, and you are going to move from CRS 3.2 to DRS 2.1, you'll see that when you move over that the actions and the statuses will default back to their original actions, right? So if you originally had put an action from anomaly score to log, once you move over to DRS 2.1, you'll see that move back to anomaly score. Now, the best method that we actually say to use when you're going from one version to the next is to use some form of infrastructure as code, and so that those specific things would carry over, those actions would carry over if you needed that. So the API specifically does support maintaining the actions and status for rules, as well as exclusions as when you move over from CRS to DRS 2.1, or even if you're moving from DRS 2.0 to DRS 2.1. So that's really the best path right there, is using infrastructure as code to preserve everything. But if you're just going to go all out and see like, hey, let's see what the false positive reduction is between CRS 3.2 and DRS 2.1, you could just do that in the portal. Everything would kind of be set to default. And then you could test from there. Actually, a quick caveat to that, what we are talking about preservation of some of the things. Exclusions, let's say for the application gateway, or in the front door as well. So exclusions that are assigned to the entire policy itself and not assigned to a specific rule group or a specific rule ID, those will be preserved whenever you moved from one version to the next. So global exclusions are preserved.
Thank you for that. Well, we have 5 more minutes to the top of the hour, so there's more questions coming in. Let me just check here. In fact, let me just publish them all, and then we'll go. If you could share the blog, Shabaz, regarding that earlier mentioning, that would be great. Is Azure WAF, or can Azure WAF be deployed only to application gateway or Azure front doors, or to API gateways and other resources?
So today Azure WAF is only available for application gateway and Azure front door. It's not a standalone product, and so you can't just deploy it for APM or web app services or anything along those lines. You'll have to put those against an application gateway or a front door.
Thank you for that. Next one goes, does Azure WAF also have capabilities to inspect HTTP responses?
No, so it doesn't today. It only looks at the HTTP request that comes in from the client, but it will not inspect the HTTP response.
And thanks for the feedback. We have somebody asking, hello, are you going to add WAF triage workbook for Azure front door? So that's definitely in the radar. Shabaz is saying thanks for that.
Yep.
Are you going to add WAF triage? Oh, okay, so this is, I think it's a repeat one, sorry. If my apps only requires a single region of coverage, should I use front door or load balancer with a WAF?
So if you're going to, yeah, so I mean, this is really, yeah, this is going to be dependent on what you need, right? Front door is a global resource, right? So the moment that you create a front door profile, this profile is replicated across the entire globe to all of our point of presences or our POPs. And so if you don't have customers in, Europe and you only have customers in the US, it might not be necessary, but that doesn't mean not to use front door, because there are a lot of great, features that comes with with front door. And of course, one of them is being that you could utilize a WAF. Typically, though, we would say, let's say you're just a region-specific customer and you know that all of your customers are based in the United States. We would probably typically say, hey, it might be better for you to utilize Application Gateway. You could use some form of traffic manager and to send requests to these different application gateways if you wanted to. I will say, though, when it comes to should I use a front door or load balancer with WAF, today, Azure WAF cannot be associated with an external load balancer or anything like that. So a load balancer with a WAF, that would have to be some type of third-party appliance. But you can look at the Azure Application Gateway as a load balancer with a WAF. So if you wanted to do that, you could do that. And that's kind of what I was saying. If you're region-based, utilize Application Gateway with WAF. And then if you have multiple application gateways, say you have East US 2 deployments, West US 2 deployments, you could utilize Traffic Manager at that point to load balance across your different application gateways rather than using front door.
Thank you. Mick is thanking you for answering the questions. And we have the last one, or maybe, yeah, I think this will be the last one. Sorry, folks, we're just getting here to the end. So if somebody's inquiring if there's a sample repo of the Terraform with DRS to share, that would be great. And
I don't think we have anything in our repo today. Actually, with Terraform, no, I don't think we have anything in our repo today that shows how to utilize DRS 2.1 in Terraform for Azure WAF. There might be one out there, especially it might be in, specifically in the HashiCorp reference material. But for our GitHub repos, we don't have anything today.
Cool. Thank you for that. Well, thank you again, David and Shabaz, for being our guests today and for sharing this great information with our community. And also would like to thank our SMEs here that were helping with the Q&A, Gustavo, Andrew, Salim, and I think I didn't miss anyone. And of course, the co-hosts here, Jason and Stephanie. So for those of you who may have additional questions on the topic we just covered or other product related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/ANS community. Thank you all for being a part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.